Alright, you guys, so we'll be working through this RNA transcription, translation, and mutation worksheet. I didn't put a spot for it, but do yourself a favor and write your name at the top so that when you take a picture and submit it, I know it was you that did it. I mean, you don't have to. You're going to submit it under your name anyway. Okay, I digress. Here we go. So, it said here's a strand of DNA. And it said the strand contains a gene and its promoter region. So first we need to circle the promoter region in blue, draw a yellow box around the TATA box, and then draw a green box around the start codon and a red box around the stop codon. Alright, well we can assume that this top strand up here, this is going to be our antisense strand. Antisense strand, this will be our sense strand. And so the sense strand is going to read just like the RNA transcript that gets made. And so if I want to, I can kind of travel along and look for the start codon, because the start codon is going to be AUG. But that's after it gets transcribed into RNA. In the DNA, it'll say ATG. And so I'm just going to scan along until I find an ATG. Well, there's one right there. Right, that could be my start codon. It could be. I don't know yet. Scan along. Oh, there's another one, ATG right there. Cool. And then my stop codon is going to be UGA or something like that. So I'm going to scan along. There's a UGA there, but hold on. If I'm going every 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. Oh, look, there's my stop codon right there at the end. That makes sense. So I'm going to circle my stop codon in red. So my stop codon's in red. My start codon is going to be in green, and I think it's over here. This is going to be my start codon, that AUG right there. My TATA box is going to be before the start codon, the area of A and T rich region. So that's going to be the TAs right here. So that's my TATA box. And then ultimately, my promoter region is going to be everything before the start codon, to include the TATA box. So that's my promoter region. So I've got promoter region, TATA box. This stuff here, like where that ATG ended up, that's going to be a transcription factor binding site. So that's where the transcription factors will come in and bind to it, kind of open up the strands of DNA and allow the RNA polymerase to start copying. The RNA polymerase will bind to the top strand. That'll be our template, but the copy that it makes will read identical to the bottom strand, to that 5' to 3' strand, other than T's becoming U's. All right, so now it says, imagine that the gene got transcribed into RNA. What would it look like? Well, let's think. So it's going to have A, U, G. That's going to be our first codon. That's that green box right there, that green circle. And then it'll be CGA. And I'm going to do this in groups of 3 because that's every 3 is a codon, and so that's going to help me when I go to translate. So I got CGA. CGA is the next one. GTT, which will be GUU. GCC, GCC. AGC, AGC. TTT, which will be UUU. GAC, so that's GAC. GUA, GUA. CCC, CCC, it's a long gene. GTG, GUG, right, because the T becomes a U. And then AAU, AAU. GGA, GGA, and then another AUG, and then finally UGA. It's kind of going off the page over there. The reason it went off the page is because I left these gaps in between the codons. All right, so anyways, that's our RNA strand running 5' to 3'. And it says before that RNA strand can be translated into amino acids, a few modifications must take place. So what are they? Well, this is the post-transcriptional. So what we did was we have our gene, we transcribed it. Now our post-transcriptional, so after the transcription, modification. So the first one is we're going to add a GTP 5' cap, or a 5' GTP cap, however you want to say that. And then we're gonna, so that'll go up here, so they'll put a GTP there. Sorry, we'll put a GTP there. And then at the end, we're gonna put a poly A tail. So a poly A 3' tail, and that's just a bunch of A's that go on the end of that, right? See all the A's I'm adding? And then the last thing is it'll be spliced. So spliced, where introns removed, exons glued together. Okay. All right, now using a codon chart of your choice, one can be found here or here, so you guys can get your own. Translate the above RNA transcript, assume that we didn't splice anything out, right? And then write the 3-letter abbreviations for each amino acids using these codons, okay? So that's what we're gonna do. So, look at that, I have a codon chart, I printed it off for us. So what we'll do is we'll start with the first one. The first one is AUG, and then I'll cross them out as we go. So we got A, well, son of a, this codon chart is for DNA, obviously. Well, a couple different ways you can use a codon chart. Some codon charts have U's instead of T's. Some of them have T's instead of U's, but they all read the same way. So AUG would be the same as ATG, and so what that codes for is methionine, so that's our MET. So that goes right here. Oh, somebody already did it for us, look at that. Okay, the next one is, so we kind of put an X next to that. The next one is CGA. So I come over to my chart, CGA is arginine, ARG. So I'm going to write that in the next circle, ARG. The next one, so I'm going to cross that off. That was our CGA. Now the next codon is going to be GUU. So I come over to my codon chart and we go GTT. That looks like it's going to be valine every time. VAL. So that's my next amino acid, VAL. All right, the next one, so I cross that, I put a little X next to it so I know we've done it. The next one's going to be GCC, Gilbert Community College. GCC becomes ALA, that's alanine. Back here, ALA, we'll cross out there. Next one is AGC. So I go AGC, serine, SER. So SER, cross that out. Next one is UUU. UUU, what you doing? TTT would be the same as UUU. So UUU would be phenylalanine or PHE. So PHE, check. And then the next one is GAC. So you've got GAC is aspartic acid, ASP. ASP. Cross that out. Next one is GUA. So we go GTA is valine. VAL. Cross that one out. CCC is our next one. CCC is proline, PRO. PRO. And then our next codon is GUG. So we come over here. GTG would be valine again. All right, let's cross that out. AAU. AAT would be asparagine. ASN. So ASN. 2 more to go. We got GGA is the next one. So we've got GGA is glycine every time. GLY. And then finally, we already know what AUG is. We don't even have to look it up. AUG is methionine. That was the first one we had. And then UGA is stop. So we just translated that whole strand well, he's translated the whole RNA strand into a strand of amino acids. All right, Now look at this. It says, imagine a mutation took place in the original DNA strand. Uh-oh. What type of mutation was this, and what effect did it have on the polypeptide? Well, man, what are we going to do here? Let's take a look. So we're going to have to compare the two. All right, so we know that, let's see, our gene started at AUG, right? So I'm going to just circle. That's where we started. That's our AUG. So it looks like it used to read CGA right after that first codon. So CGA was what it used to read. Now it reads GGA. Okay, well that was a single base pair substitution. That means that instead of it just flipped. Instead of the C being on the bottom, it flipped. Now the C's on the top and the G's on the bottom. So now the codon reads GGA. So what type of mutation was that? That was a point mutation. Or you could say like single base pair substitution if you want to be fancy. Okay, what kind of effect did it have on the polypeptide? Well, let's find out. It used to read methionine arginine. Arginine was coded for by CGA. Let's see what GGA codes for. Now GGA codes for glycine. Uh-oh. So what type of mutation was it? It was a point mutation. What effect did it have on the polypeptide? It changed the amino acid. It changed the amino acid. So what type of mutation was this? Point mutation, base pair substitution, but with the effect of a missense. It was a missense mutation because it was a single base pair substitution or a point mutation that changed the codon to read for a different amino acid. All right, let's flip the page. Ribosome activity. So this one's pretty easy. All we got to do is label the different parts, right? So we can actually do it by letters if we'd like. So first it says label the large subunit. So to me, F, that's this right here, F is the large subunit. And so I'll just write large subunit out here. I mean, you can write it in there too if you want. It's up to you. And I'll cross that out. The small subunit, well, shoot. There's nothing labeled for the small subunit. So I'm just going to go and call that, let's see, we got A, B, I don't see a C, so we'll call that C, and I'll call C the small subunit. So the large one's up there, the small one's the jaws down below, clamping in our mRNA transcript. Okay, and then we want to label our E, P, and A sites. All right. Well, we can just write these into the ribosome. What it looks like is this first site right here is where this is where the tRNA is entering the ribosome. So that has to be the A site. I'll just label that right there. That's the A site. The site where the growing chain of polypeptides is, that's the P site. That's the polyadenylation site. And then this last site where it's exiting, that's the E site. So there we go. EPA. Great. All right, now let's take a look. The tRNA. Let's label tRNA. Well, B up here, that's a tRNA. That's a tRNA. The growing chain of amino acids, well, that's these guys, right? Tryptamine, phenylalanine. So that's letter A is the growing chain of amino acids. Okay, so cross that out. The mRNA transcript, well, that's got to be G. G is pointing to the mRNA transcript. Transcript. Okay. Codon, well, the codon is going to be each one of these three-letter designators that are labeled D. So D is going to be our codon. Anticodon, well, we find the anticodon on the tRNA. So letter E is pointing to that three-letter designator that's on the tRNA bringing the amino acid for that particular codon. And so those 3-letter designators, that's E is going to be the anti-codon. And then the amino acid bound to tRNA. Well, let's see. I don't see any labels there. Amino acid bound to tRNA. I could label any of those. So this one right here, that's the amino acid bound to the tRNA. Okay. And that's it for that. Now, I want to change one thing on this paper, and I'll change it right now on yours, so you probably won't even notice this. But this is not the 5' end. That's the 3' end, and this is the 5' end. And the way we know that is the ribosome is reading it this direction, right? Because it's reading it. It locked onto the 5' end. Actually, no, that's right. What was I doing? I'm sorry. Don't listen to me. I'm retarded. Okay. No, I'm not supposed to say that anymore. I apologize if I offended anybody. But the 5' end here, that's right. The ribosome is reading it from 5' to 3'. So the new ones are coming in. That's right. Okay. It's labeled correctly. I was just like messing with my own head there. All right, so everything's good. If you have any questions, feel free to reach out. Let me know. I hope you guys enjoyed it.